All right, pre-calculus. We got 2.5b exponential function, context, data modeling, data modeling. Let's take a look at our basic forms when we're dealing with a percent increase. A is still our initial amount, which you guys are all used to, and I know that maybe you've seen it as P before. I'm trying to get my pencil to show up here. AP is the same thing, just your principal, your starting amount. But now, if it's a percent increase, I want you to think of this 1 plus the percent increase, but we're going to have to write this as a decimal. And then, or if it's decrease, it's going to be 1 minus percent increase. You'll usually see this written as A1 plus R, where R is the rate as a decimal that you're either adding or subtracting. So if you're decreasing, obviously R would be negative in that situation. Okay, so let's play into this. Identify the percent increase or decrease of each function. Super simple. If I was to kind of like rewrite this, this would be 0.5, and then I could think of this as 1 plus 0.2 to the x. So therefore my R is 0.2, and so as a percentage, we would say that's 20%. So 20% increase, because we know it's an increase because this value here is greater than 1. But if I see a problem like this, again, if I was to rewrite it, I got to think of this as 1 minus what to get to 0.7? Well, it'd be minus 0.3. And since I'm subtracting 0.3, that would say that's a 30% decrease. So everything's either added or subtracted from 1. That's our baseline. Go ahead and try this one on your own, and pause the video, and then check back when you're ready to check your work. Okay, so to get down to 0.025, you'd have to subtract 0.975. And so as a percentage, you could say that's a 97.5% decrease. Again, because it's less than 1. Hopefully that's what you got. All right, let's move on here. Got a couple of word problems here. It says create a function to model the scenario. So these are all going to be written in this format here. We might add, we might decrease, but that all just depends on the context of the problem. So a home value, V, is $200,000. Okay, so V equals $200,000. And it increases by 1.5%. So that's going to be 1 plus. Now I got to write 1.5 as a decimal, which would be 0.015. And then per every year T. Boom. There we go. Of course, you could clean this up. We could say, by the way, con, just for the record, con does not like commas. 1.015 to the T. There we go. Easy peasy. Let's take a look at the next one. A population P of fruit flies is currently at 150. So P equals 150. But it's increasing by 200. Oh my gosh, that's too many fruit flies. So that's going to be 1 plus 2.05, because again, to write this as a decimal, just move it over 2 spots. And then per every day, D. And you could write this as P of D. And so what is that going to end up being? It's going to equal 3.05 to the D. Easy peasy. All right, why don't you try the next two on your own, see if you could figure it out, and then unpause the video when you're ready to check your work. All right, so for number 6, they tell you that it's decreasing by 28.1%. So convert that to a decimal and then subtract from 1. There's your equation. Boom, easy peasy. For number 7, they're telling you it's decreasing by 14.7. Again, convert that to a decimal and then subtract from 1, and you have your equation. Pretty simple, pretty straightforward. Okay, these are some common formulas come up. We come up with half-life and doubling time. Here's what it's going to look like. You're going to start with your principal value again, A, and you're multiplying by half, and so T is your variable in both of these. What you want to do is you want to divide by the amount of time it takes for that halving to occur. In this situation, it's H, right? Because it's saying it shrinks by half every H, whatever that is. Maybe it's every hour, maybe it's every minute, who knows what. Over here, if I'm doubling, the equation looks very similar. A times 2, because we're going to multiply by 2. And then this is going to be divided by every D. D meaning, it's every day. It doesn't have to be a day. It could be like an hour, a minute, a year, whatever. But D for doubling, H for half, whatever that unit is of time. Okay, so let's go to the next problem. there's 150 grams of radioactive material. Its half-life is 4,400 years. So that right there is like your H, because that's how long it takes for it to go into half. So if I use that formula from before, it looks kind of like A 1/2, and we said T over H. Well, since our H is 4,400 years, I'm going to say the initial is 150 grams. Multiply that by 1/2, T to the 4,400. Oh. All right, and now we have our equation right here. Perfect. My T looks really funky, but that's just a T. Okay, that's a half-life. Let's talk about the doubling life. Let's see. Mr. Bean's parents currently have 95 descendants. Sheesh. The number of the descendants doubles every 15 years. Okay, so my basic doubling formula is T over whatever the doubling rate is, and it's saying it's happening every 15, so that's my doubling rate. So Y equals initial amount of 95. We're going to double that every 15 years. So again, we're dividing by the unit time. Kind of what you could think about this is, if I was to plug a 15 in here, that'd give me a 1. And so 2 to the 1 means I'm multiplying this by 2. So that would mean that it gets doubled. Like, it ended up being 1. It'll be doubled exactly right. Because we'll end up just multiplying by 2. If it was 30 divided by 15 is 2. So then you have 2 squared because you're doubling it twice and so on. So eventually you're going to multiply by 2 every 15 years this way. That's why we're dividing, to kind of make this a nice even 1 once we get to 15. Okay, so sometimes they're going to give us a problem in a certain format. Like, for example, here they're giving us this equation, and they're telling us that T is in weeks, every week. But we could rewrite this to represent different units of times depending on what they're asking for. So if you think about it, they're also giving us this. You could rewrite it like this, okay? So the reason why we're allowed to do this, by the way, is if you think about this, this is 1.01 to the 52 to the T over 52. Well, whenever you have an exponent to an exponent, you're just multiplying. And if you were to multiply this 52 times T and then divide by 52, these would cancel and you'd be back with your original amount. And why would this represent year? Well, we know that there's 52 weeks in a year. And so we can just divide by that rate of weeks per year. And let's kind of think about this. If I was to plug in a 1, right? If T equals 1, well, what would that look like? It'd be 1.01. 52, oops, let's do another set of parentheses, 1 over 52. And this should make sense because if I'm trying to get to a year, isn't one represented weeks originally, isn't 1 week 1/52nd of a year? And so now I have a year going on here. So like number 10 says, if f of d, 3d indicates the quantity increased by a factor of 3 every day, so we're tripling every day, then what would this represent? Well, let's just kind of think about what 1/7, again, just kind of plug in a 1. You'd end up with a 1/7, where this is a day. Well, 1/7 would represent, must be like, if that's a day, then 7 would have to indicate that we're saying it's a week, right? So, right, 1/7, if we're talking about 1 day, 1/7 is 1 day of a week, right? Or 1/7 of a week. So that's what we're going to say here. This would represent the change per week, or tripling every week. So you're going to look for those little conversion factors. Just whatever they're dividing by, that's kind of your hint of what they're going to changing it to. So look for those things. Like another example is, like, what if I was to say, okay, this thing is going to be f of t equals, I'm just making something up here, 5. And let's say it's growing by 1.5, so 50%. And I said, I started off with t, and I said, hey, this is every hour. Okay, and then I rewrote it, and I said, but what if I wrote it like this? Right, okay, now if I plugged in a 1 here, what's 1/24th? And you're thinking of hours. Well, 1/24th would be 1/24th of a day, so that 1 hour would represent 1/24th of a day, right? So you're kind of looking at those little conversion factors, and keep in mind some of the rates you already know, and how to interpret what that function might mean. Okay, that's it for now. I'll see you guys on the next video.